It's a pleasure to be here, and thanks to my friend Morgan for the fantastic presentation you just had. And we're actually gonna build on that. So today I really want to talk about decision-making AI for the enterprise. And as you know, it's been a hectic time in AI. And the key question, I'd say the trillion-dollar question is this going to continue, or is it a bubble? And what are the implications for industry in terms of next-generation tech? And essentially, progress, as you know, has been driven by data, compute power, and also fundamental progress in models. I think the example we saw from Dassault Systèmes is really a compelling one about how granular you can get into data integration and being able to derive insights from data using Gen AI. But what's interesting also is that there's potential to go even beyond, and AI keeps opening new opportunities that are additive to what exists already. And so, yes, it's a triple exponential. You guys know that. This has been the case for something like 15 years now, since the beginnings of the deep learning revolution. And the interesting new thing, if you want, is that AI is now accelerating itself. That is the new thing. It's we're basically at a paradigm shift. And what do I mean by that? I mean, some of the researchers that were involved with the first progress we've seen in AI back in the time of solving Atari games, etc., deemed this, and notably Richard Sutton, the godfather of reinforcement learning, deemed this the age of experience. So essentially, we've been seeing three phases in terms of progress in AI. The first one was reinforcement learning on simple games. Where are games interesting for RL is because you know exactly what to optimize for. You have an explicit score, and this has driven fundamental progress, sort of peaking at the level of AlphaGo, AlphaZero, with systems that, when you have perfect information, can actually, and perfect score, can deliver great capability. Then we have the wave of generative AI, starting with ChatGPT in November 2022, and leading until now. And what's interesting today is that we are entering a new era, which is all about this idea that AI is so good that in an agentic form, it can actually build its own experience and accumulate its own data. So what do I mean by that? If I revisit the three engines, basically, AI is going to boost them massively now. For example, in data, this was mentioned before, you can basically drive data generation, but data generation that's not coming from humans, data generation that's coming from AI systems. So think about, for example, materials design, materials optimization. It's AI actually that's going to decide which particular sort of molecules to test next. Test those, get that feedback, and from that infer again, and at the same time read all the literature in real time, and so on and so forth. Same in medical space. So essentially, it's AI driving data now rather than humans driving data. This is extraordinarily important because it means that you do not have humans in that context, and that means that things can move much faster fundamentally. Same thing in compute. Technologies such as reinforcement learning and optimization mean that the next generation of NVIDIA GPUs, next generation of Google TPUs are actually driven by optimization and humans. So it's co-designed by AI, which explains actually the faster cycle. Don't know if you've noticed, but now NVIDIA is more on a yearly cycle in terms of next chips. This is coming from AI. So again, AI driving compute progress. And the last one, models. When you think about optimization techniques, well, now models are so good, reaching levels at 80% software bench tasks. So essentially, most of software tasks can be done better by AI than by humans. And this means now that you can have systems that actually go all the way, complete very advanced software tasks in the beginning 20 minutes, now several hours, in the future several weeks, entirely autonomously. And so this is opening a new paradigm, which is this notion of accelerated learning thanks to data. So it's not hey, you're going there and checking this and that and this particular information and insight. It's actually AI driving the entire system. And at InstaDeep, the company I co-founded, we are pioneers of both the innovation in terms of fundamental innovation in reinforcement learning and optimization, but also concrete use cases. So we participate in major conferences, push the state of the art, but what's interesting is we're actually deploying this in practice, and we don't have too much time, but I'll show you two examples that build on what was presented before by Morgan and others. This first one is on actually railway scheduling. This is an insanely complex problem. If you think about it, like a country like Germany has more than 20,000 train rides a day, and you have an ability to deploy AI at several levels. Of course, digitizing the infrastructure, data capture, and the edge. We had a panel on this morning, but also automating completely the driving of the trains. So this is so far classic. What's less classic is this notion that you have a single system that's going to optimize the entire fleet deployment, railway deployment across a large country like Germany. This has never been done before, and actually optimizing a system at this scale is an insanely hard challenge. Any industrial process is complex, but here we're talking about looking at the infrastructure of an entire country, modeling precisely the physics of every train, every weather condition, disruption, and other. And you have a system effectively that is learning by doing in simulation and then deploying in the real world. But even on a simulation basis, this is a very difficult problem due to the complexity of all the configurations. Think about like keeping security distances, managing disturbances. And this is where actually agents driven by reinforcement learning and other optimization techniques are actually going beyond what a human can do. Humans, we have limited intuition at the end of the day when you take a problem at insane industrial scale, and this is where actually smart decision-making systems and distributing them in the right way can actually go well beyond what's possible before. And so it becomes not just a case of deriving insights from the system, etc. It becomes a case of actually making big decisions about allocation and reaping the benefits. When you think about the infrastructure, when 1 kilometer of railway, the cost is easily in the hundreds of millions of euros, if not billions, to build, depending on the topography. Well, imagine that for the same actually railway infrastructure across an entire country, you are now smarter, which means you can have actually more traffic, more usage of that critical infrastructure. Well, that's an immense gain, and that's what actually agentic AI and this era of experience can derive. So when we started this project with our partners at Deutsche Bahn, we were essentially the first in the world to tackle it at this large sort of scale. Now it is confirmed that the approaches we pioneered are actually working, and I expect to see many more use cases in the industry, essentially using the fact that we have digital twins, like you have seen previously, which are extraordinarily detailed, but using this as a foundation, as the basis for decision-making systems at a very large scale that are using those comprehensively. So this is an example. I'll show you another one which I think is interesting, which is the work we've been doing to optimize operations in a large airport, in this particular case, Frankfurt Airport, with our partner Fraport. And again, the problem here is insanely complex. You have 1,000 flights a day. We're talking about all between 150,000 to 200,000 passengers every day. You have large ground crew teams that need to, in real time, react to sort of like the traffic flow of planes. And of course, there are delays, disturbances here and there. So you need to manage those things. And the question becomes, what is not an optimal allocation, but actually a very effective allocation compared to what is being done in a heuristic manner. Again, very hard problem where you need to model the entirety of the operation and deal with the stochasticity of what's going on. And this is not a case where, hey, you can just get some supercomputers to run for a few hours and give you a solution. You have to adapt in real time. And that is something that, again, is done well with those technologies initially pioneered for Atari games, but are now mature enough to be deployed in industrial scale. And so the notion here is really like have a system that continuously learns how to allocate, in this case, ground crews between different tasks, and how to dispatch them and how to effectively deploy them across the entire airport. And what's interesting here is if you train the agentic system well, it will actually be able to come up with great potential solutions at inference time. And inference time is extremely important. This means that you are not spending so much time to optimize and get a solution. This is happening fast. And so that is critical here, because it means that as the situation evolves, as weather conditions evolve, disturbances happen or not, some planes arrive earlier than expected, others later than expected, you can actually reevaluate the entire operation of the airport when it comes to ground crews in near real time. Every 4 minutes, you actually have an entire new allocation. And so the system we're operating in near real time. So think about an industrial asset you have, whether it is a factory or a nuclear power plant like we've seen, or any other complex asset that has operations happening, you can leverage the fact that you now have digital twins that are advanced to plug in this decision-making capability in a comprehensive and unified manner, and that is the new thing. So my expectation is that we're going to see a lot more of that in the future. Actually, the age of robotics that is upon us, we're going to see the first, I would say, practical, real-world use cases of humanoid bots in next year. This is going to even increase this further, because you could have end-to-end modeling of the entire industrial asset or industrial system that you have, and so learn in simulation how to better use it. So fundamental progress is coming soon, and it's coming soon because with those technologies you can really adapt quickly. Again, this is not the notion of having sort of like a rigid plan which is supposed to be optimal, but hey, in practice it doesn't work at all because things change so quickly. It's this ability to constantly readapt and have a continuous learning through that. So at InstaDeep, that's what we do. It's really an entire new era. I want to emphasize again that is what is new here is the fact that data generation in terms of like decision-making, outcomes, better understanding of the critical industrial asset that you have is actually going to come from AI directly rather than be driven by people. And when you think that in the very near future, we're going to have systems at supercomputing scale that can solve these things in simulations, but also robotic systems with IQ potentially in the 150, 160, having a multimodal understanding, being very effective in the factory. This is an entire new set of industrial opportunities that is coming, and that we are like working at InstaDeep to help our partners sort of like seize in terms of like making the best out of these big opportunities. So I'll stop here. Happy to take some questions if you have, and thanks a lot. Yeah.